We're going to start Chapter 7 by talking about proportions. Chapter 7, for the most part, is about similar triangles and similar polygons, but we need to be able to understand proportions to be able to do that. So, let's go ahead and start with this ratio. Total number of students out for a fall sport is 204 of a school that has 1,900 total students. The question says, what is the ratio of athletes to total students? Okay, so let me get some space in here. Move that down. Okay, so ratio of athletes to total students. So a ratio can be written in a couple ways. We could write it as A to B, or we could write it as a fraction as A over B. For this one, I'm going to use this first one. So their ratio of athletes to total students. So the number of athletes is 204. The number of total students, 1,900. The second part, this shows up on a quiz and on the test for this chapter as well. What is the ratio of athletes to non-athletes? So I know 204 athletes, but the common mistake is we get the second number wrong. There are not 1,900 non-athletes. Instead, because 204 of those people play sports, that means 1,696 do not. And one thing that I forgot as I go through this, you want to simplify the fractions. So you want to take 204 over 19, and you want to simplify that. So when I simplify this fraction, 204 over 1,900, you're taking your calculator and doing this, and this simplifies to 51 to 475. Oops. 51 to 475. And when I take 204 over 1696, and I simplify that, I have 51 compared to 424. So you always got to remember to simplify your ratios. And just to go into ratios a little more in depth, it's a comparison of two quantities. We can do three quantities, but more often just the basic definition of ratio is two quantities. Ratio can be written three different ways. I already showed you two of them, A to B, A over B, or just writing it out, A to B. So let's look at an example that's actually talking about triangles now. We have a triangle that has three sides with a ratio of 5 to 12 to 13, and the perimeter is 90. Whenever we see a ratio, we've already done this part in previous chapters, is whenever we see a ratio, we always put an X after it. And I know that those have to add up to the perimeter. Let's change that to 3. And the perimeter is 90. This is one of the very few instances where you actually add the sides up and set them equal to 90. The only reason I'm doing that is because it says that's the perimeter. So 30x equals 90. X is 3. I need to find the measure of the shortest side. Well, the shortest side is down here because it has the smallest ratio, and 5 times 3 gets you 15. Let's look at another one. A 2x4 piece of wood is 48 feet long. If it is divided into two lengths with a ratio of 1 to 3, how long is the longer piece? Okay, so we have a piece of wood where the entire piece is 48 feet long. We want to split it with a saw so that this piece is 1x, this piece is 3x. Because we have a ratio, we always put x's after. So 1x plus 3x equals 48. When you go through and solve this, you're going to get x is 12. Now that I know x is 12, how long is the longer piece? We're looking for the longer piece, so we plug 12 in, and we get 36 feet. So a proportion is two ratios that are equal. So whenever you simplify a ratio, setting those two equal to each other, you actually get a proportion. And then you're able to do the cross product, which we've been calling cross multiplying. If I cross multiply that, 4 times 10 is 40, and 5 times 8 is also 40. So cross multiplying works when the proportions are equal. So let's try solving for y. I'm going to cross multiply. 3 times 24 is 72. and 8 times y. We get y is 9. Now we've done stuff like this already. Cross multiply 8 times 5x, that's 40x. Now I'm going to take 4 and I'm going to multiply by everything on this side. And to avoid mistakes, I highly encourage you to write it out in 2 steps. 4 times 2, now it's 8x. 4 times 8, that's 32. When you go through and solve, you subtract 8x, so 32x equals 32. X is 1. Now let's put this into a real problem. A twin jet airplane has a length of 78 meters and a wingspan of 90 meters. A scale model is made in proportion to the real airplane. If the wingspan is 36 centimeters, find the length of the toy. Okay, so when you look at this, you have the wingspan and then you have the length. So the wingspan, let me change colors, of the real airplane is 90 meters. The length is 78 meters. Now on our model over here, it's a scale model, so we know the wingspan of this one is 36 centimeters. Let me rewrite that. And we know that the length is something we don't know. So what I'm going to do is I'm going to take this information that's given and set up a proportion. You have a couple different options. You can set up one full ratio for the real airplane. The length over the wingspan is equal to the length over the wingspan. Or I could set up a proportion, let me switch colors here, wingspan over wingspan is equal to length over length. And the reason those are the same, and the reason that you can do that and it doesn't matter, is because when I cross multiply 90 times x and 90 times x, 78 times 36 and 78 times 36. What you have to be careful is that it matches. If you do wingspan over wingspan, you have to go back to wingspan over wingspan, but notice the 90 and the 78 are in the same spot. If I do length over wingspan, I have to do length over wingspan. And that's the only requirement. There's a couple different ways you can always set these up, but you have to be sure that you're setting that up properly. When I do cross multiply, 2808 is 78 times 36. That's equal to 90x. So when I divide by 90, I get 31.2. And because we're talking about the model, that's 31.2 centimeters.